So in this lesson, we're going to combine a lot of the knowledge that we've learned in previous lessons. So the first example, a college uses SAT scores as one of the criteria for admission. Experience has shown the distribution of scores among its entire population is in the table below. So we have this mean for the math score of 625, mean for the verbal or reading score is 590. Standard deviation for math is 90, standard deviation for verbal is 100. We want to know the mean and standard deviation of the total SAT score. So basically, we're finding what is the mean or the expected value of math plus verbal, and then what is the standard deviation of math plus verbal. So we're taking what we learned last class and applying it to a new problem. So for expected value, our kind of trick was expected value always says what we expect it to. We're just going to add the numbers. So 625 plus 590, which is 1215. A little math in the head there. So that would be the mean of the combined score. Now for standard deviation, what we would do is we would add the variances. So our rule for standard deviation was that we can't just straight up add standard deviations for two different variables. We have to add their variances and then work backwards. So in other words, we're going to add their variances, so 90 squared plus 100 squared, right? And that would give us the combined variance, and then I'm going to square root that to get back to the standard deviation. So I had called this the Pythagorean theorem of statistics because we can't just add standard deviation. So I'm doing a little math real quick in my calculator, which would give me a standard deviation of 134.5. That would be our standard deviation. However, one of the kind of qualifying things when we're combining two different variables for their standard deviation is that we have to know that the two variables are independent, meaning that they don't affect each other whatsoever. There's nothing that would connect them that would maybe change some of these standard deviations. So in this case, we're talking about like an SAT test that you take all together in one test. You're not like, it's not you're taking the two different parts separately. It's not like these are different students. These are the same students. And generally, people who do better on one section are also going to do better on the other and vice versa. So because of that, we can't really say that they are independent variables. So we really can't find the standard deviation of the combined score for this one. So we would say, can't calculate because we don't know that these two are independent variables. That would be how we do it if we knew they were independent, but we don't know that and they're probably not. So we can't calculate that. We would have to leave it blank.